Hello everyone, welcome to this tutorial. My name is Emerson Ahori, I'm a Google Earth Engine expert. In this tutorial, I'm gonna show you how to get land subsidence data from the Earth Engine platform. The land subsidence data is available in the awesome Google Earth Engine data community. As you can see, there is a website entitled Awesome Google Earth Engine Community Catalog that you can come here and look for different data that is not directly available in the Earth Engine. This is a very perfect website, allows you to look for remote sensing data and products regarding to your purpose, and then you can bring them or connect it to the Earth Engine and use the data for the further processing in there. For example, if you go to the Google Earth Engine data catalog, you cannot find the land subsidence data in the date I'm producing this tutorial. But if you go to the awesome Google Earth Engine community catalog, this website, that its link is already mentioned below the video on my YouTube channel in the description box. Here you can go to the data catalog and try to find your target data easily. And this website data set, including most of the data already developed by the remote sensing community in different papers and journals, and all of them gathered together here and allows you to use them without any challenge. For example, here I'm gonna find the land subsidence data. There are two solutions. The first, search the desired product, and the next one is go to different categories. As you can see, we have different categories here, and below the geophysical, biological, and biochemical data here, you can see the global land subsidence mapping is available. All of the products has a citation in this website, and here you must cite the citation if you want to use this product in your research or in your job. And also there is a code example here, as you can see, directly connect you to the Earth Engine and allows you to call this data and see the example and etc. It's very useful website, and also all the data published under a specific license, and here there is a link to the GitHub repository, and if you want access to the paper or the article prepared this data, you can easily find it from here. So now in this tutorial, I'm gonna show you how you can call this product in the Earth Engine and how you can visualize the actually land subsidence variations or probability for different regions of the world. Hopefully this product is global and you can use it for all around the world. So the first, as you can see here, we have two kinds of data. The first is land subsidence probability, and the next one is recorded land subsidence. I prefer to start with the probability map. Just copy and paste it into the Earth Engine. As you can see, I'm pasting this data set. This is a single image for whole of the world, prepared based on the data available since 2013 to 2019. So here, but I prefer to change the name for it's very long name, and also it's very difficult to write the code and deal with such kind of the name. I'm suggesting you to make it shorter, for example, as probability here. Now, if you print the probability map in the right panel, after a few moments, you can see that we have one image that is available for whole of the world. It has only one band, and this band includes the probability of land subsidence for the whole of the world. So, through the map.add layer, or map.add layer allows you to do the visualization for this product. So let's do the probability map, mapping the probability layer for the whole of the year first, and then I will show you how you can clip it based on your region of interest. So the visualization parameter, as it has a single band, now you can define a palette color, because this is a stack, this is a single layer with a single band. And if it was if it has multiple bands, but then you cannot make a palette. So make a palette here, just like that. For example, I'm gonna have a palette from a combination of these colors: white, yellow, orange, and red, as you can see here. Or we can have another colors such as brown and black. It's totally up to you what kind of palette you want to use. And the layer name is probability, and use the false at the end to avoid automatic visualization. Remember to save your code and run it again. So there is a problem here. The black is wrong. Now the problem is solved. After a few moments, you have a new layer as a probability layer. So the probability layer based on the polar palette shows the probability of land subsidence from white to black. As long as we go toward the black, such as red, brown, and black, meaning that the probability of land subsidence gets higher and higher. For example, in the red regions and black regions, the probability of land subsidence is higher than the yellow and white regions. There it is. And also in Iran and arid and semi-arid regions in the Asia, as you can see, highly suffered from the land subsidence probability. So there it is. And as I'm from in Iran, I know that over the last years, we had a lot of land subsidence in the arid and semi-arid regions, specifically in those areas that are a center for agricultural activities in the central part and south and northern part, as you can see here. So now imagine that I'm gonna actually make a land subsidence layer for my own country or for my region of interest. It's totally up to you how to do the visualization or the area you're gonna select, no matter where you wanna do this process. Just you must actually call this data as much as same as I did, and then try to do the visualization without any challenge and clip it based on your region of interest. So, for example, I'm gonna make a layer as Iran because I'm gonna actually show the land subsidence for a part of Iran. Let me to do this for a part of Iran. For the whole of the Iran, it might be very complex, and also because of the processing steps and volume of pixels engaged in the processing increased, and we may face with a lot of issues about the processing and etc. I prefer to select a small basin. For example, as you can see, if I zoom in my own country in the northwest of Iran, around the Urmia Lake, here we have a center. Here is a big center for agricultural activities, and as you can see, seems because of very big agricultural activities and heavy extraction from the groundwaters. Over the last years, we faced with a lot of land subsidences in the east region and central part of Iran. So now I prefer to select a basin layer or the basin that covers this area. So through the drawing tools available, mark this region or the region you prefer to work, no matter where you want to do this process. Just you can use these tools and code for your region of interest. So here now I'm gonna call the basin layer through the search places and dataset. Just call the basin. After a few moments, you can see different hydroshed basin level or hydroatlas basin layer. If you type for hydroshed here, after a few moments, you can see hydroshed basin layers level number 5 we commonly use here as a table. Now let me to define the region of interest first. ROI equals to, from input filter, I'm gonna filter it based on the location of based on the location I have selected that is already known as a geometry. Now, if you want to do the simplification that is necessary for the shapefiles to actually facilitate the processing speed in the Google Earth engine, you must make a map and also a function inside to do the simplification for each layer available in this table, filterable table. So the function returning the input feature that is simplified based on a degree we set here. For example, 1000 is a degree I set for the for simplification process. The higher value, greater simplification, and vice versa. So now through the map.add layer, I'm going to show you the region of interest. First, let's have a focus on the region of interest through the map.center object, map.center object ROI, and map.add layer and ROI. After a few moments, you can see we have focused on the study area, and now you can see the border of the region. Let's remove the geometry sign here and then make a layer and also make a new probability layer. So now I'm gonna have the probability layer for the ROI here, or we can make probability ROI equals to, so the image, probability image that's clicked based on the region of interest or ROI. And then we can make another map.add layer here, but this time we want to see the probability layer for the ROI and also the same palette color for the region of interest. As you can see, the palette color selected, the same one we want to use for our study area, and the layer name is ROI probability, and use the false at the end to speed up processing and avoid automatic visualization in the Earth engine. Click on save and run it again. After a few moments, you can see the ROI for probability layer for region of interest, the land subsidence image for the region of interest. As you can see, the reddish area, yellowish, and also the orange area, all of them shows the region suffering from the high probability of the land subsidence. So there it is. And also if you go to switch to the inspector and click on each pixel, you can see the value of the probability, the higher value, higher probability, and vice versa. And also the white region, lower probability. The red region, yellow region, and orange region, all of them related to the area, all of them related to agricultural area and agricultural centers, maybe because of high extraction from the groundwaters caused such kind of subsidence in this area. There are a lot of reasons behind the land subsidence, and only one of them is extracting water from groundwaters. So at least I know over the last years in my own country, because of heavy extraction from the groundwaters, we faced with a lot of issues about the land subsidence. But it may have different reasons also. So, and if you back to the data characteristic and data description here, there is another layer that shows you how much land subsidence occurred based on the centimeter, from 1 centimeter to 10 centimeter, or different threshold here. If you select the next variable here and paste it, as you can see, the first one is related to the probability, we don't need, but the second one is land subsidence. So here I called it as land sub, this is a recorded one, and now we want to visualize this product for the whole of the world first. Through the map.add layer I showed you before, again we can repeat the map.add layer, this time for the land subsidence. As we wrote it before here, just copy and paste it again, but this time for land subsidence based on the centimeter. This is different classes that shows how much land subsidence occurred, how much, for example, the land lifted down, for example. So save your code and run it again. So now we have a new layer as a class, and I want to increase the contrast. As you can see, that based on 90% of values, the minimum is around 1, the maximum is around 8 or 9. The units is centimeter. 1 is 1 centimeter land subsidence, and also the 8 means 8 centimeter. Actually, the measure is a measure of the land subsidence. Click on apply here, and after a few moments here, you can see you can increase the contrast by actually different values. And as you can see, the black regions, the white regions shows almost 0, but the regions with yellow and black, red and brown color shows we had around 8 centimeter land subsidences. For example, in the Iran near to Tehran as a capital here, if you go to the satellite, and also if you want to remove the no data pixels, the simplest way is the self mask. For example, I'm going to use the self mask for the land subsidence layer to get rid of the no data pixels to have a better visualization here. Self mask and run a code. After a few moments here, the class layer is available, but this time I hope fortunately it doesn't work here. I don't know why. We can use another method such as update mask. For example, I'm gonna let's see what kind of values we have in this region. This is value number 1. This is not value. If it was value number 0, then we could remove it. So let me to use the update mask first. Update mask from land subsidence layer. Remove the pixels equal to 1, for example. Run a code again. Not equal to 1. Yes, problem is solved, and now you can see the regions that seriously suffering from the land subsidence in different levels. So now increase the contrast by 90% of values, and as you can see, for example, this region is close to Iran's capital. The region highly suffering from the land subsidence, its values is around, for example, through the inspector, you can see the value should be around 10 centimeter. 10 centimeter land subsidence occurred in this region based on the estimations. If you select the orange region, for example, it is around 5 centimeter land subsidence. So that's a technique or simple technique that allows you to understand how much land subsidence occurred in your region of interest. Now I'm gonna actually make another layer that is clicked for the land subsidence here. Just a new variable created. Now land subsidence for the region of interest equals to get the first or initial land subsidence and clip it based on the region of interest, and through the mapped add layer we can do the visualization for this layer also. The land subsidence based on ROI with the same color palette and ROI class. Run a code. Now you can see the result only for your region of interest. Here is ROI classes, increase the contrast, and now click on apply. The previous output, ROI probability, as I mentioned earlier, only shows the probability of a land subsidence. Maybe land subsidence not occurred in real world, but the ROI class shows how much, for example, the Earth's surface downlifted or lifted toward the down because of the land subsidence. And the amount of the land subsidence can be detected through the pixel values we have in this output. So, as you can see, the real downlifting here, if you click on pixel, for example, here we have 5 centimeter. For some regions, we have around 10 centimeter. That's completely matched to the regions under agricultural activities. So now I'm going to show you how to get export from the output. Maybe you want to get export from probability or the land subsidence ROI, no matter which one of them. Maybe you want to use both of them in your study for the further studies. The simplest way to get export and bring it into desktop software is export.image to drive. Couple of arguments should be considered here. The first is the image you want to get export from. So the image equals to, now I'm gonna get, for example, no matter probability or land subsidence, one of them. The method is same for both of them. You must select your data first and then clip it based on the region. If it is already clipped, same as this example, you don't need to do the clipping process again. Just description shows the name of the layer output, because the layer output will be a TIFF or GeoTIFF format, and it must have a actually name here. The description name here is, for example, land subsidence example, and a scale of output could be, for example, 100 meter, and I couldn't find any information about the pixel scale or spatial resolution or actually the spatial resolution values. Here there is an example code that you can use it to get more information about these products. If you click on this link here, you can see an example about the code that is already provided by the authors here. But as you can see here, we cannot see any information about the spatial resolution, whether in this page or in the data description. But no matter, because I think the 100 meter, based on what we are watching here, seems the spatial resolution could be around between 200 and 500 meter. But if you set the resolution as 100 meter or 200 meter, have a good consistency with the spatial pattern that we can see here. So, and the region of interest equals to the ROI, the region of interest, and maximum number of pixels we can have in each output equals to 1E13, and CRS or coordinate system equals to EPSG 4326. This is a single code that we use for WGS84 as a popular coordinate system for all around the world. No matter where you are working, for all of the world, you can use this code as a coordinate system. And the target folder that you want to save your data in could be test or any other folder you want to have with any name. So remember to save your code and run it again. Switch to the task until your data gets ready for saving process. Land subsidence is unsubmitted yet. Click on run, and here you can see the data characteristic, and click on run. After a few moments, the process of saving is started, and as you can see, as soon as the tabs color turn to the blue, same as previous example, meaning that the output is ready to pick up from the Google Drive, and then you can open it up in your desktop software. no matter which software you are using, actually the output will have a GeoTIFF format, and also it is readable in all geospatial softwares, whether it is ArcGIS or QGIS or Snap, NV, and any other software related to geospatial data analysis. The code examples and also the data reference link is available below this video on my YouTube channel. In the description box, you can compare yours with mine, your code with mine. If you had any problem, you can reach me out on YouTube channel and put your comments there. I hope you liked this tutorial as much as I did. Thank you for your attention.